our channel Electro for you. So today we will start with atomic and ionic sizes. So for determining the atomic size of an atom, first we have to see what is the radius of that atom. So let us understand first what is atomic radius. So it is the distance between the center of the nucleus of that atom to the outermost shell containing electron. So let us understand this with this diagram. Here, as we can see, this is the positively charged nucleus and these are the shells containing electrons. So the distance between the nucleus and the shell which contains outermost shell which contains electron, that is called atomic radius. So we can measure atomic radius with so many methods. First one is X-ray diffraction, second one is a spectroscopic method, and many more methods. And for measuring atomic radius, the units are nanometers, Armstrong unit, or picometers or meters. So one nanometer is equals to 10 Armstrong units, and 10 Armstrong units is equal to 10 to the power minus 3 picometers, and that is equals to 10 to the power minus 9 meters. So in the periodic table, as we move from left to right, that means along the period, what happens? The size of the nucleus get increased, and also the electrons are added in the same shell, due to which the attraction force on the outermost shell get increased, and that's why its size gets compressed and the size gets decreased. Now let us see this example. Here in this atom, as we can see what happens along the period, the size of the nucleus get increased. That means the attraction force of the nucleus will also get increased, and the electrons are added in the same shell. Okay, in the same outermost shell. So what happens, the size, here we can see that the size remains the same, but the size of the nucleus, due to the increase of the size of the nucleus, the attraction force on the outermost electron will also get increased. That's why it will get compressed a little, so its size will get decreased. So along the period, the size of the atom gets decreased. Now if we see along the group, that means from top to bottom, there the new shells are added along with the electron. Here the size of the nucleus remains the same, but a new shell is added along with an electron in that shell. So due to the increase in the number of shell, what happens? This shielding effect get increased, because as we can see that for this shell, now we have three innermost shells. For this outermost shell, now we have three innermost shells which are shielding, which are acting as a shield in between the nucleus and the outermost electron. So here this shielding effect is getting increased due to the increase of the electron along with the shell. So, due to increase in shielding effect, the attraction force of the nucleus on that outermost electron get decreased, and that's why the size gets increased, because it will move away from the nucleus. So the size will automatically get increased. So along the period in a periodic table, the size of the atoms get decreased, and along the group in a periodic table, the size of the atom get increased. So now we will see what is covalent radius and Vander Waals radius. First we will start with covalent radius. So it is half of the distance between the nucleus of two covalently bonded atoms of the same element in a molecule. So let us see with this example. Here these two atoms are of similar element, that is X. Okay, so the distance between, and also these two atoms are covalently bonded, that means they have made a bond, I mean they are bonded with each other by sharing electrons between them. So this is called covalent bonding, and the distance between the nucleus of this covalently bonded atoms is d. So the covalent radius for this will be d divided by 2. That is the half of the distance between the nucleus of two covalently bonded atoms. and let us assume it as R1, covalent radius as R1, and let us assume the actual radius of this atom X, individual atom X, be R. So R will be always greater than R1 and R1 will be always lesser than the actual radius of that atom. Now we'll see what is Vander Waal radius. So it is half of the distance between two non-bonded isolated atoms. So here, as we can see, these two atoms are isolated and also they don't have any bonding among each other. So the distance between these two, distance between the nucleus of these two atoms is d dash. So the van der Waals radius will be d dash divided by 2. And let us assume van der Waals radius as r2. So as we can observe that the van der Waals radius will be always greater than the actual radius of that individual atom. That means r2 will always be greater than r and r1 will be always lesser than r. Thank you for watching this video. If you like the video, then please hit the like button and also subscribe our channel. Thank you.